All right, so here we are at number 27. We are still solving the equation. And again, to save us just a little bit of time, I went ahead and rewrote the original equation here. And we know by now that we are going to go through and factor each of these denominators. And that's going to help us to find a common denominator, which will then in turn help us to clear the fraction so we can solve for x. So x squared minus 9, well, we know that's x plus 3, x minus 3. And x squared minus 2x minus 3, well, that's going to be two binomials we know. So factors of 3 that subtract to give us negative 2. So how about x plus 1, x minus 3. And here, again, we know two binomials. And factors of 3 that add to positive 4. How about x plus 1, x plus 3. All right, so now that we can see all of the factors, we want one of each thing that is unique. And we're going to multiply the entire equation by that common denominator. X plus 3, x minus 3, x plus 1. All right, so it looks like our common denominator is x plus 3, x minus 3, x plus 1. So let's go ahead and plus 3, x minus 3, x plus 1. Write that above each term. So x plus 3, x minus 3, x plus 1. All right. And now comes the fun part, getting to cancel what's common. So let's see, x plus 3 goes away, x minus 3 goes away, and so we're left with quantity x plus 1 times quantity x plus 2. So let's go ahead and FOIL those things out and see what we get. X plus 2. All right, x times x, well, that's x squared. X times 2 plus 2x, 1 x and plus 2. If we combine our like terms, we get x squared plus 3x plus 2. So x squared plus 3x plus 2. All right. X plus 1 gone, x minus 3 gone. So we're left with now x minus 3, x plus 3. Let's go ahead and FOIL these two things together. And hopefully you recognize these as being conjugates, right? Everything's the same except for the sign. One's plus, one's minus. Well, that means that we can just do, instead of foiling the whole thing, we can just do FLE, the first to first and last to last. And so we end up with x squared minus 9. You could go ahead and FOIL this whole thing out, but you'll see that the two middle terms cancel. So we have plus x squared minus 9 equals, and now plus 1, x plus 1 gone, x plus 3 gone, and we're left with now quantity x minus 3 times the quantity 2x minus 3, 2x. So let's FOIL this together. X times 2x, well, that's 2x squared. X times minus 3 minus 3x minus 6x plus 9. We'll go ahead and combine like terms. So 2x squared minus 9x plus 9. 2x squared minus 9x plus 9. Good deal. All right, let's go ahead and combine like terms here on the left. So we can combine our squared terms, and we can combine our constants here, can't we? All right, so we end up with 2x squared plus 3x, and then we have minus 7, right? 2 minus 9. And then equals 2x squared minus 9x plus 9. All right, well, it looks like we have a quadratic equation here. So let's get everything to one side and set the equation equal to 0. And then factor. So subtract 2x squared, subtract 3x. We're going to move everything from the left to the right. And then plus 7. So minus 2x squared minus 3x, and then plus 7. So everything cancels here on the left. And now here on the right, we're left, oh, look at that. The squares actually go away. So we're not left with a quadratic equation. We're going to be dealing with just a linear equation, aren't we? So that makes things a little easier for us. Well, let's see. Minus 9x minus 3x, well, that's going to give us minus 12x. And then 9 plus 7 will be plus 16 equals 0. And if we want to solve for x, we'll subtract 16 from both sides. That leaves us with negative 12x equals negative 16. We'll divide by negative 12, divide by negative 12. And so x equals positive 4 thirds, right? 4 can go into each of these numbers. So 4 goes into 16 4 times, 4 goes into 3 3 times, and a negative divided by a negative is a positive. And last but not least, we want to make sure that this solution, when we plug it back in, doesn't make any of our denominators 0. So on a test, you certainly want to make sure that you're doing that. If we were to do that here, we would find that we don't get a 0 for any of these denominators, and so we don't have to worry about dropping this answer. This is a valid answer. All right, let's take a look at number 28. I'll see you there.